Welcome to saitechinfo channel, my dear students. In this tutorial, we will be studying about cations and anions and how to form compounds based on that. Cations means positively charged ions. Anions means negatively charged ions. Let us consider the monovalent. Monovalent means single valency. Monovalent cations, and these are monovalent anions. So here we have ammonium, NH4 plus. This is known as ammonium. Cesium, Cs plus. So almost metals and some combination of elements or group of elements like ammonium, they may have plus charges and its oxidation number is +1. Likewise, gold plus hydrogen plus lead plus lithium plus potassium plus etc. Similarly, we have anions. So it can either be a monovalent single atomic anion like a chloride ion, bromide ion, chloride ion, cyanide ion. In fact, cyanide ion, it consists of two elements, and fluoride, single element, hydride, single element. So H minus, hydroxide, it consists of two elements, O and H, with the negative charge. So likewise, hypochlorite, ClO minus, iodate, IO3 minus, iodide, I minus, nitrate, NO3 minus, nitrite, NO2 minus. Likewise, we have got various ions. In this case, bisulfate, that is HSO4, bicarbonate, HCO3. Similarly, we have bromate here, BrO3, bisulfite, HSO3 minus. So likewise, we have monovalent ions. So one monovalent cation can combine with one monovalent anion. Let us consider cesium. So Cs plus, that combines with, we can take here chloride ion. So let us consider chloride ion, this one. So Cl minus. So that gives CsCl. So make sure that these two oppositely charged ions combine so that the net oxidation state is 0. So this one is called oxidation number. +1 is the oxidation number of cesium. -1 is the oxidation number of chlorine. Okay, so by combining these, now the charges are nullified to get cesium chloride. So likewise, it can have 1:1 combination. For example, you can take sodium, Na plus, that is this one, sodium, and combine with HSO3, that is bisulfite. So plus HSO3 minus. So this is +1, this is -1. So they get neutralized to give NaHSO3, which is nothing but sodium bisulfite. In fact, in Indian English, we use for sulfur pH, and in American English they use F for sulfur. Okay, so we can maintain pH as well as Indian standards are concerned. And similarly, we have barium 2 plus, barium 2 plus. So they are called divalent anions, cations. Okay, and what about this? They are called divalent anions. Okay, now barium 2 plus, beryllium 2 plus, cadmium 2 plus, calcium 2 plus, cobalt 2 plus, and usually these charges can be represented as Roman letter within brackets. So cobalt 2 plus, copper 2 plus, iron 2 plus, and iron 2 plus can also be called ferrous. In olden days, they used to call ferrous. Okay, ferrous. Then lead 2 plus, magnesium 2 plus, manganese 2 plus, mercury 2 plus, etc. And in fact, this is actually it is a dimer. Even though it is a 2 plus, it has got a Hg plus, so this is known as Hg 2 plus is mercuric and Hg plus is mercurous. But it is being a dimer, you can put 2 plus. Okay, so it's a dimer ion. That is, two atoms are joined together to form a resultant plus 2. So, and this is mercuric, mercury 2, and this is mercurous 1, and that is why they put mercury 1. Are you able to understand this? Mercury, it is dimerized, actually Hg plus, but it is dimerized. That is, two atoms are joined, so Hg2 2 plus. Similarly here, mercuric, this is mercurous, this is mercuric. Normally lower oxidation states are mentioned as ferrous, Fe2 plus. Ferric means Fe3 plus, higher oxidation state. So nickel 2 plus, strontium 2 plus, zinc 2 plus, tin 2 plus. So similarly we have carbonate anion, CO3 2 minus, chromate ion, CrO4 2 minus, dichromate, Cr2O7 2 minus. So likewise it goes, oxalate ion, silicate, sulfate, etc. Now we can combine these two. For example, let us consider barium with the 2 plus, and let us have the CO3 2 minus, so that we are able to get BaCO3. Okay, so barium carbonate. So the charges are neutralized, and the net oxidation state of barium carbonate is 0. Are you able to follow? So what is the oxidation number of barium? It is plus 2. So oxidation number is nothing but the valency represented with its charge, that's all. Then CO3 2 minus, so 2 minus, that is minus 2 is the oxidation state of carbonate anion. Okay, so likewise we can combine straight away with the divalent cation and the divalent anion. Similarly trivalent, for example aluminium 3 plus, chromium 3 plus, cobalt 3 plus, auric, that is gold 3 plus, ferric, that is iron 3 plus, manganese 3 plus, and we have anions, arsenate, ASO4 3 minus, ASO3 3 minus, that is arsenite, and this is citrate, and this is ferricyanide. So N3 minus, nitrite. Now let us try to combine 3 and plus 3 with minus 3 anions. So let us consider aluminium 3 plus. Let us combine with phosphate. So PO4 3 minus. So straight away you can write AlPO4. Okay. And similarly let us consider iron Fe3 plus. That combines with, and here you have got, that is ferricyanide. You can simply put Fe and then Cn, then 6, and this is 3 minus. So they can combine as Fe, open the bracket like square bracket, is called coordination compound. So Fe, in order to distinguish this complex ion, so we can put it in the bracket. So Cn6, that's all. So this 3 plus and 3 minus, they combine to form a neutral oxidation state here. Are you able to follow? Right. Now, so far we discussed the combination of monovalent with the monovalent cation with the monovalent anion, divalent cation with the divalent anion. Just like that you can combine these two ions, and similarly trivalent with the trivalent anion, trivalent cation with the trivalent anion. And we have 4, for example SN4, tin, nickel 4 plus, and similarly lead. Let us consider nickel. So in the case of nickel, can we combine with for example phosphate once again, or nickel nitrate? So how we can write? You have nickel 4 plus N3, that is nitride minus. So that gives, now we must ensure that the charges should be neutralized. So what we can do, we can multiply this by 3 and this by 4. So 3 4s are 12 plus, 4 3s are 12 minus. Now we can write the molar coefficient of the subscript, that is atomicity. So Ni3, because we have put 3 times. And what about N? that is 4 times. So this is nickel 3 nitride. Are you able to follow? So this is the way you have to write down. For example, can you suggest the formula for calcium phosphate? How we can write calcium phosphate? Can be written like this: calcium Ca2 plus, phosphate is PO4 3 minus. Now, as I already told you, we must ensure the neutral charges for the resultant product. So here 2 plus 3 minus. So take LCM, that is 6. So this can be multiplied by 3 and this can be multiplied by 2. Therefore 3 2s are 6 plus 2 3s are 6 minus. Now you can put Ca, and this 3 should be written as the subscript Ca3, and PO4 you cannot write 2, otherwise it looks like 42. So put bracket and put 2. So this is called calcium phosphate. Okay, so got it. So shall we try? That is you have got Cr2O7 2 minus. What is that? Dichromate, is it not? So this one, dichromate. Okay, let us combine with any compound, like for example, that is manganese. Okay, manganese Mn2 plus. So manganese Mn2 plus. Now what will be the formula? This is 2 plus, this is 2 minus. So straight away you can combine. So MnCr2O7, that's all. If it is a potassium K plus Cr2O7 2 minus. Now you can combine. So plus, this is minus, so multiplied by 2. So 2 plus 2 minus cancel. Now you can put K2Cr2O7, potassium dichromate. Okay, right. So you have to memorize all these anions and cations of different charges, and you should be able to write down the equation based on this. Okay, thank you for watching this video.